Welcome back. I'm just showing here the two mesh current equations that we found last time, okay? We might call this one here, we could call it equation 1, and we might call this one here, we could call it equation 2. All right, so how many unknowns? There are really just two unknowns. Now, you could use whatever technique you want to, really, to find I1 and I2. You may be able to use your calculator to actually do that. Look, if we were going to do it, just now, using a simple mathematical approach, what we could do is have a look at this guy, have a look at this guy, and see what we could actually eliminate. Well, look, if I took this equation number 1 and I were to multiply equation number 1 by 3, and I took equation number 2 and I multiplied by 4, then let's see what we would get. So taking the first equation here, multiplying by 3, what do we have? We have 60 is equal to what? I1 times 4k. 3 4s are 12, so that's what? 12k minus I2 times what? 3 3s are 9k. Okay? Let's look at the second one. 4 times 10 is 40 is equal to what? I1, there's a minus there, don't forget, so there's the minus. 3 4s are 12, so that's 12k. And I've got a plus I2, 4 5s are what? 20k. Now if we look at this, I'm trying to eliminate one of the terms here, either I1 or I2, but look, if I were to simply take those two and add, then I've got 60 plus 40 is 100, and that is equal to, well look, I've got a plus 12k I1 and then a minus 12k I1, and so that's gone, these go, and I'm left with what? I've got a minus 9k I2s and a 20k I2s, so I'm really left with what? Yes, I'm left with I2 times 11k. And so therefore I can say that this I2 is simply equal to 100 divided by 11k, and if you care to work that out, and I'm just going to round a little bit here, I'm going to say that is a 9.09 milliamps, okay? And so we've found I2. If we now take this I2 and we substitute it into either one of these equations, I'm going to choose equation number 1 there, what do we have? We have 20 is equal to I1 4k, and I've got a minus, well, I2, let's put that in. I2 is 9.09 milliamps, and that is what? Multiplied by 3k. Well, so the only unknown here is really that I1. So let's just take this a step further. That's 20 is equal to I1 times 4k. And let's evaluate this over here. What do we have? We have a minus, so if I do this, I have a minus 27, and again a bit of rounding, 0.27 volts, okay? So I'm going to take this over to the other side. That gives me 20 plus that 27.27, so that's a 47.27, and that is equal to what? I1 times 4k, and so therefore I1 is really equal to this 47.27 divided by that 4k, and that comes out to be about 11.82 milliamps. And look, please go ahead and check these numbers. All right. So look, finally, having found I1 and I2, we can find anything else in the circuit. If we want to know the voltage across the 1K resistor over here, it is simply this I1 times 1K. Want to know the voltage across that 2K resistor, it's going to be simply the I2 times the 2K. And similarly, if we want to know the voltage across that 3K resistor, we can say it's the I1 minus the I2 times that 3K. All right, I'll see you next time.